If I were you, I'd also be tired of using that shitty external Triggerbot that you pasted from unknown cheats. Luckily, I'm Kaz, and today we're going to talk about tracing rays and making yourself a real Triggerbot. Now, a Triggerbot is a cheat feature that detects exactly what you're looking at, determines if it is an enemy, and then shoots for you. This type of cheat is extremely effective when holding corners or angles. Often, Triggerbots will also come with a few customizable options, like adding a delay to the shot to make yourself appear more legitimate, or only shooting when aiming at a specific hitbox. In Source Engine games, if you have enough IQ points, you will be able to access the EngineTrace interface, which allows you to call a plethora of functions, but there is one in specific that I'd like to show you. This function is aptly named Traceray, and it does exactly as it seems. It traces a ray from one point in the world to another point and returns whatever it hits along the way. Now, if your neural pathways are still intact, you might be able to guess exactly where I'm going with this. By tracing rays from our eyes in the direction that we are looking at, we can accurately and efficiently detect exactly what we are looking at, and if that happens to be an enemy, we have ourselves a sexy Triggerbot. But before we get into making your next premium feature, if you'd like the source code to this video and many more, check out my Patreon down below. I also have a Discord server where we chat shit, so join us over there. And finally, if you enjoy this content and would like to see more, be sure to drop a like and subscribe. Anyway, without further ado, let's hop into Visual Studio and get coding. Alright, so I'm going to be using Visual Studio 2022 for this video. Once you have it open, go ahead and create a new project. We're going to use an empty project, name it whatever you want, and hit create to make your project. Once Visual Studio has opened, navigate to the top and switch from debug to release, and then switch from x64 to x86. We do this because Csgo is in fact a 32-bit game, and therefore we are required to build a 32-bit DLL to work with the game. Now, because we created an empty project, we are going to need to change a couple of our project's properties to make it build exactly what we want. To do that, navigate to the left, right-click on your project's name, and then select Properties at the bottom. Immediately at the top of this window, make sure Configuration is set to all configurations. This is so that when we change settings, it will apply to both our release and debug profiles. Of course, at the moment, we are only going to be using release mode, but if you do want to debug later on, this is going to save a massive headache. Next, make sure Platform is set to Active Win32 because we want to set up our properties for x86 builds. Now, in general, set your output directory to solution directory/build and do the same for your intermediate directory, except add the intermediates folder after the build folder. Next, change your configuration type from application.exe to dynamic-library.dll. This is because we do want to build ourselves a DLL which we will be injecting into the game. Finally, set your C++ language standard to preview so that we can make use of the latest C++ features. Now go over to the advanced tab and switch your character set from Unicode to multibyte. This just makes life a lot easier when using the Windows API. The last thing we need to do is go to linker, system, and make sure that your subsystem is set to subsystem Windows. This is because we are going to be building a Windows dynamic linked library, and this will indicate to the compiler that we do want to use the DLL main entry point. Remember to hit apply, and then you can exit out of the properties window and we can move on. I've designed the structure of this project to be consistent and expandable so that you'll be able to reuse what you code here in the future. This means that we are going to be creating quite a few files and folders, so bear with me here. As the tutorial progresses, you'll begin to see how they all link together, but for now we're going to get it out of the way by making everything. In your Solution Explorer, at the top, go ahead and click the Show All Files button. This will show your project as it is laid out on your disk. Begin by creating a build folder. This is where you will find your compiled cheat DLL when you do compile the project. In this folder, also go ahead and create an intermediates folder. This will hold all of the random files that are generated when you build your project. Next, make an ext folder. Ext is short for external or external dependencies, and this folder will hold any external libraries that we might use. In this video, we are going to be using the minimalistic hooking library, so go ahead and create your MinHook folder in here. Finally, create an src folder. src, of course, meaning source. This folder will hold all of our cheat source code. In this folder, create a CPP file, which I'm going to call main.cpp. This file will hold our DLL main function and naturally serve as the entry point to our application. Now go ahead and create 3 folders in here, those being core, util, and valve. Core is to contain the main components of our cheat, so in here we are going to create a few files. Globals.h, hooks.cpp, hooks.h, interfaces.cpp, and interfaces.h. We will discuss these in detail a little later. Util is going to include all of our miscellaneous or helper code that we are going to be using. For this project, we are just going to add a single file called memory.h, so go ahead and do that. Finally, the valve folder is going to hold our Csgo specific classes, structures, and interfaces. For this project, I've decided to prefix all of our classes with the letter C and all of our interfaces with the letter I. You can consider this our SDK folder. Let's begin with our our classes. Create the following: CEntity.h, CUserCmd.h, and finally CVector.h. Moving on to our interfaces, add the following: IClientEntityList.h, IEngineClient.h, and finally IEngineTraceClient.h. Here is a screenshot of what your entire project should resemble at the moment. So take a second to confirm that you have everything, and if you do, let's go ahead and move on. Now, before we actually start coding, the last thing we need to do is get the MinHook source code. I will have a link in the description to the MinHook GitHub repository. Navigate over there and hit the nice green code button to download a clone of the source code. In my case, I can find the zipped file inside of my downloads directory. Go ahead and open it up, navigate to the src folder, and we're going to drag and drop all of these files into the MinHook folder inside of our project. Next, find the include folder inside of the clone that you downloaded and drag and drop minhook.h into your MinHook folder alongside all of the other files. Back inside of Visual Studio, we still see that our MinHook folder is empty. So at the top of the Solution Explorer, click the blue refresh icon and you will notice that Visual Studio is now aware of the MinHook files. But pay attention to the red icons next to each file. This is because we have yet to actually include the code inside of our project. To do that, right-click on your MinHook folder and select Include in Project. We're almost done, but remember, because we actually changed the locations of the MinHook source files and the include files by putting them in the same folder, we are going to need to update this in MinHook. So go to the hook.c file and under the commented license, remove all of the relative directory stuff so that it just becomes #include minhook.h to fix the error. With that out the way, let's start coding. The first component of our cheat that we are going to tackle is the memory file. So inside of your memory.h file, firstly #include c standard int, and then we're going to go ahead and create a namespace aptly named memory. This namespace is going to hold two help functions that are essential to our cheat. The first will help us call virtual functions without needing the entire interface, and the other is going to return the address of any function inside of an interface. Begin by creating a template with two types, those being return and args respectively. Please take note of the three dots in between type name and args. This is known as a variadic template. Now create a function called call with the return type of return, and we're going to make it a constexpr function so that the compiler will optimize it where possible. This function will take three parameters, those being a void pointer to the interface, an unsigned int for the index of the virtual function that we want to call, and finally the arguments that the virtual function takes. We're going to create a function type definition called function to help us call the virtual function. This will return the type that we specify as return, and quite importantly, it'll use the thisCall calling convention. This is because in C++, any function that is a member of a class, besides static members, have a hidden parameter in the first position, which is the this pointer of the class it resides within, and this is represented by the thisCall convention. Therefore, the first parameter of this function definition will be a void pointer, that being the this pointer that we just discussed. As for the rest of the parameters that this function takes, we will use the decal type keyword to deduce the types of the arguments passed into our variadic template. All that is left to do is to actually call the virtual function. To do this, firstly we need to access the underlying virtual method table of the interface, which is essentially an array of function pointers. This is done by casting the interface pointer to a double pointer of the function definition and then dereferencing the result. This will give us access to the VMT, which we can then index like any other array. Of course, we're going to index it to the index that we pass into our call function, and now we can use brackets to actually call the function. The first parameter will always be the this pointer, and the rest of the arguments will be the variadic arguments that we passed into the function, just like so. The next function is essentially the same thing, but instead of calling the function, we just wanted to return a pointer to the function at the index of the virtual method table. We will use this function to hook virtual methods later. Create a function named get that takes an interface pointer and an index that returns a void pointer. Next, cast the interface pointer to a triple pointer and dereference it once to access the virtual method table and return the function at the specified index. And that concludes our memory namespace. In the description below, you will find a link to a paste bin which contains the code we will use for our CVector class. Go ahead and copy paste it into your CVector.h file. This is an extremely simple 3D vector class that holds 3 floats. It has the operator overloads that we are going to use in this tutorial, and most importantly, it includes a 2-vector function. Angles and vectors are both data structures that hold 3 floating point values, but obviously they need to be used differently. This function will take angles, for example your view angles, which are 3 float values, and convert them into a positional vector inside of the world using trigonometry based on how the game's positions, angles, and view matrices are laid out. Don't worry too much about the math, look it up if you really want to, but we're gonna move on. Down below you will find another pastebin link which contains the CUserCmd class that we are going to be using. Throw that into your project too inside of your CUserCmd.h file. User commands are sent from the client to the server with information that the server needs to dictate dictate your movement requests. I go into a lot more detail in my video on hooking the CreateMove function, but this class will allow us to both access our view angles and modify our input commands to make our local players shoot and eventually accomplish our Triggerbot, which we will use later on. So once you have that, let's move on. Alright, it is time to stop pasting for a little bit. We're going to make an entity class that gives us access to a couple entity virtual functions that will allow us to get information about the entities that we will hit with our arrays. Start by including your memory.h file and the CVector.h file. Create a class called CEntity, don't forget your public access specifier, and then add the following functions: get team, is alive, is player, get eye position, and finally get aim punch. Now the functions themselves are pretty self-explanatory, but I'd like to take a second to explain how we are calling these virtual functions, because we are going to be using this a lot and I do want you to understand it. Taking a closer look at the get team function, we see that it returns an int and takes no parameters. Pretty simple, but here we are making use of our memory call function. Take note that we have passed the same data type into the template as our function returns. We are also passing in the this pointer to our CEntity class. This means that when we have an entity of type CEntity later on, the pointer to said entity will be passed in as the first parameter, so that we can access the virtual method table of the entity that we have. Of course, the final parameter is just the index of the virtual function in the table. In this case, it is at index 88. I hope that makes sense, so let's move on. The IClientEntityList interface is crucial because it will allow us to easily get our local player. Begin by including CEntity.h and then create a class called IClientEntityList. We're going to have one function in this class. We will call it getEntity from index, and it will return a pointer to a CEntity. The function looks like so, and when passed the index of any entity inside of the player list, it will return a pointer to said entity, which will allow us to then call those juicy virtual functions inside of our CEntity class. The IEngineClient interface is awesome because it will allow us to easily get the index of our local player so that we can use it with the IClientEntityList interface. Begin by including memory.h, CVector.h, and finally CUserCmd.h. Now create a class by the name of IEngineClient and add the following functions: get local player index and set view angles. Once again, pretty self-explanatory, so let's go ahead and move on. Unfortunately, we have to revert back to our old ways because I have one last thing for you to paste. Once again, down below, navigate to the IEngineTraceClient pastebin link and go ahead and copy paste this code into your IEngineTraceClient header file. This includes three important classes: CRay, which describes the ray we want to trace, CTraceFilter, which specifies which entity we do not want to hit, and finally CTrace, which contains the entity that our ray finally hits. These are all required to use the Traceray function. Of course, right at the bottom we find the IEngineTraceClient class, which includes the infamous Traceray virtual function that we are going to use later. Alright, no more copy pasting from here on, I promise. Regardless, that completes our SDK and everything we need to get started in our cheat, so let's get going. Moving on to the core of our cheat, we're going to start in globals.h. Since this project is relatively simple, we only need one global variable, and that is going to be our local player. So let's create a namespace called globals. Now, since our local player is an entity like any other player, we want our global local player variable to be a CEntity pointer, and therefore we need to include our entire CEntity class, right? Well, no. Let me introduce you to something called a forward declaration. Outside of our namespace, we are going to type out class CEntity semicolon. Now think of this as a promise of sorts. We are telling Visual Studio that somewhere in our code we have a class called CEntity, and luckily for us, Visual Studio will trust us. Now we can declare our local player variable as a pointer to the CEntity class, but also note that I use the inline keyword. Since this file is going to be included everywhere, variables in it are going to get redefined over and over, but of course we don't want this. We only want a single local player variable. Therefore, we make it an inline variable, which essentially tells the compiler that we only want a single one of these to be made. Any global variable that you make in a header file needs to be inline. Alright, now this is where things get juicy. Inside of interfaces.h, we are going to create a neat little namespace to manage all of our interfaces and bring everything together. This is the backbone of our cheat. We begin by including that globals header file that we just created, and then we are going to include our three interfaces from our SDK like so. Now we can create our interfaces namespace and declare our two functions. The first one is pretty simple. We'll call it setup. It returns nothing and takes no parameters. This function will capture all of our interfaces in a single call. The next one is going to require a template. We'll make it return a t pointer and call it capture. It's going to take two C strings as arguments, and it will be used by our setup function to get each interface pointer. Finally, we're going to define our interface pointers here. Create an inline class pointer for each one of our interfaces and initialize them to null pointers for the time being. Now we're going to add two extra interface pointers here that we haven't spoken about yet, but these can both be void pointers and and that is going to be client and client mode. We have not made classes for these two because we don't need to call any of their virtual functions to do what we want to do in this video, but they do play a vital role in our cheat. We need the client interface so that we can get the client mode interface, which is required to hook the CreateMove function, which is where our Triggerbot is going to run. We'll get into that in just a little bit, but for now we need to define the two functions we declared above. So let's hop into interfaces.cpp and include the interfaces header file just like so. Next, we are going to include the Windows SDK because we are going to be calling a few Windows API functions. Since we declared our functions in the header file, we need to define them in here. We can leave the function bodies empty for now. Just remember the interfaces namespace before the function names. We're going to start with our interfaces capture function. This function is going to make use of the exported create interface function found in CSGO's modules. Firstly, we are going to use the get module handle function from Windows to get a handle to whatever module we pass into our lib parameter. We'll store it in a variable called handle and make sure it is not null. Now we're going to make a function type definition of the exported function mentioned above. Now we can get the address of the function in the module using getProcAddress, which we can cast to our function type def so that we can then call the function. Now we can return a call to create interface, passing in the name of the interface that we desire. Moving up to our interfaces setup function, we're going to use our capture function to get the address of each of the interface pointers like so. The entity list pointer can be found in client with VClientEntityList 003. The engine pointer can be found in engine with VEngineClient 014. And finally, the trace pointer can be found in engine.dll with EngineTraceClient 004. As for those other two interfaces, the client pointer can be found in client.dll with the name of VClient 018, but the client mode pointer is not so simple, unfortunately. To get this pointer, we're going to access the function at index 10 of the client interface like so. Then we're going to add 5 because that is where the pointer is located inside of the function. And then we'll cast all of this to a void triple pointer and dereference it twice, giving us the client mode pointer. I go into a lot more depth about this in my CreateMove hook video, so go check that out. But this wraps up our interface manager, so let's get into the hooks. In your hooks header file, the first thing we are going to do is include our interface header, and then we can create our hooks namespace like so. We're going to start by declaring two functions, those being setup and destroy. Setup is going to place all of our hooks, and destroy is going to restore them so that we can neatly unload our cheat later on. We'll define these functions in a moment, but for now we need to lay out the structure of our CreateMove hook. Firstly, we'll create a type definition of the CreateMove function. Pay attention to the thisCall calling convention and the first parameter being a void pointer. We need this type definition so that we can make a function pointer to the original CreateMove function, which we can make like so. Finally, we actually need to declare our CreateMove hook. This is the function that is going to get called when the game tries to call CreateMove. Moving into our hooks source file, firstly include your hooks header file, then include MinHook from your external dependencies. Now we can create the definitions of our three undefined functions like so. Take note of the hooks namespace name before each function. We can leave them empty for now as we tackle each function one by one. Starting with our setup function, we're going to call mhinitialize to initialize MinHook. We are then going to call mhCreateHook, passing in the address of CreateMove along with our hooked function, and finally where we want to store the original function so that we can call it later. Last but not least, we need to call mhenableHook to activate the hook, and we can pass in mh_all_hooks to enable all of our hooks. And that wraps up our setup function. Moving on to our destroy function, this is going to be relatively simple. We're going to call disableHook, removeHook, and finally uninitialize to clean up our hooks. Alright, this is the moment that you have been waiting for. We now have everything required to make our Triggerbot. This is where everything up to this point comes together right here in this CreateMove hook. The first thing we're going to do is call the original CreateMove function and store it inside of a boolean called result. This is because depending on what the game wants this function to return, we have to perform some logic that we'll go over in just a little bit. Next, we're going to check if the user command's command number is 0, and if it is, we're going to return out of the function. This is because if command number is 0, this function is not being called from C input CreateMove, which is where we do want it to be called from. Next, we're going to see if the original CreateMove returned true, and if it did, we're going to use the engine interface to update our view angles. This is because the game does this automatically for us when the function does return true, but we are not going to be returning true because we want to be using the most up-to-date view angles. Now we can get our local player by using the entity list interface with the get local player index function from the engine interface. We only want to run our Triggerbot code if we are in fact pressing the Triggerbot key, so we're going to use get async key state and return out of the function if your desired key is not pressed. I'll be using mouse button 5 in this case. Now we can make sure our local player pointer is valid and then make sure that we are in fact back to life because Triggerbot is a little bit useless if you are dead. Next, we're going to get our local player's eye position and aim punch angle using those entity virtual functions that we made earlier. Since eye position is where our ray is to begin, we're going to calculate the destination of our ray by taking our eye position, adding the direction in which we are looking at, which we get by adding our aim punch to our view angle so that our Triggerbot doesn't go wild when we are experiencing aim punch, converted to a positional vector that is scaled by 1000 times to extend the position. Now we create our CTrace object and use the trace interface to trace our ray. It starts at our eyes and extends to the destination that we just calculated. We're going to use the mask shot flag because we want to simulate firing a bullet. The entity that we want to filter out of this ray will be our local player, or else our ray will always hit ourselves. And finally, we want the result stored inside of the trace object that we just created. Now we want to make sure that the entity that we just hit is not a null pointer and that we did in fact hit a player because we aren't trying to Triggerbot chickens. Next, we're going to make sure that the player that we hit is alive, and quite importantly, we need to make sure that they are not on our team because shooting our teammates is never a good idea. Finally, we're going to set our buttons inside of our CUserCmd to in attack, which will force us to shoot at the enemy player that we are looking at. And to end it all off, we can return false, which concludes our Triggerbot. All that is left to do is to head over to our main.cpp file and initialize our cheat. So let's go ahead and do that. So in here, we're going to include the Windows SDK, the thread header, and our hooks header file. Our setup function is going to return a dword and take an LP void parameter. We're going to initialize our interfaces and our hooks, and then we're going to make this function sit in a slept while loop until your unload key is pressed. When it is pressed, we'll break out of the loop, destroy our hooks, and finally free the library and exit the thread to have a successful unload. Below this function, we can make our DLL main entry point. We want to check if the reason is equal to DLL process attach, and if it is, we can disable the thread notifications with disable thread library calls and create our setup thread. If the thread is created, we are going to close its handle because we are not going to be using it, and finally you can return true out of DLL main and compile your cheat. All that's left to do is to hop in game and test it out, so I'll catch you guys there. Alright, so I'm in game over here, checking out my build folder. I have the Traceray-Triggerbot DLL cheat that we are going to be using. Also have Xenos open, that's just what I'm going to use to inject for this video, so let's go ahead and inject. If I press mouse button 5, as we can see, it shoots. Let's grab an AWP or something. I'm going to hold down mouse button 5, and we get him. So that just about wraps up the video. Hope you guys enjoyed, and if you did, make sure to drop a like and subscribe, and you know, stay tuned for the next ones because they're gonna get cool. Anyway, once again, cheers guys, and I'll see you in the next one.